Hi everybody, in today's episode we are going to discuss probably the most essential topics in the Qt framework, or more precisely QObject class and the meta object compiler. So listen carefully and let's dive in. I want to start with a little bit of explaining and then we'll write an example program in the editor. The first thing I should say about the QObject class is that it is a heart of framework. It means that nearly everything in Qt inherits QObject inside. As you see here, it is the list of classes inherited by QObject. And as you see, it's like huge amount of classes. The standard C++ object model provides very efficient runtime support for the object paradigm. But the thing is, classes that don't have some basement is inflexible in certain problem domains. GUI programming is a domain that requires both runtime efficiency and a high level of flexibility. This central feature with QObject opens us very useful features in Qt to develop GUI systems. Now let me draw a bit and explain the advantages. First and foremost, the advantage is signals and slots. We will discuss it more deeply later, but for now, just think of that as if you have, for example, button, that is button, and I don't know, a mail sender, for example, the thing that sends emails. Mail sender. And you want to add some functionality so that when you click button, sender gets something and can send the mail, for example. And that is what signals and slots are actually used for. So when button is clicked, the signal that was previously connected to the slot is emitted. For example, you have here a slot. Let me move it a bit. A slot in the mail sender. Let's put it inside. And here you have signal. And when button is clicked, someone pressed it, click it, then you emitting, I don't want to write it, but you understand, you emitting the signal, and previously, before you emit it, you should connect a slot to the signal. And after emitting, every slot gonna get that signal that you have to make everything that in the slot, because slot is we can say that slot is a method or function that you just write and it later called. Second advantage, and very important one, is that objects organize themselves in object trees. Similarly to signals and slots, we'll discuss that more deeply later. But for now, you should understand that all objects, for example, one object, second object, like objects, that's all some objects that is inherited from, of course, QObject. Build the tree, so we can put like parent and child relationships, so that it automatically deletes its children in its destructor, that object. It allows to avoid memory leaks and strongly helps us to solve one of the most problematic parts of C++ language. And for example, here, let's say that object, it can be even your application. It's your app that you create at the beginning of main function. And you can set, and for example, it's your objects, some objects. And you can set application as a parent to the child objects. So after program is ended, then everything is deleted for you, and you don't have to write delete this, delete, and I mean you don't want to delete everything, all the three objects. Qt makes everything for you. And one more advantage is that the fact that everything in Qt is QObject gives us a very easy way to cast objects to certain types. And if an object has a different type from the one you want to cast, but inherits the same class, then you actually can do it. And here in documentation, we have a wonderful example. When you like here, for example, let's assume my widget inherits from QWidget and is declared with the QObject macro. We will discuss what is QObject macro later. And you can create it to specify the type QObject, and then you can cast it to the QWidget because everything is QObject. And like if you take a look on this example, if you, for example, cast it to the QLabel and it is not the same, for example, the just label is 0. And you have less problems with casting your objects because you have one base class that is called QObject. And now I know I just gave you a huge amount of information, but now let's open the editor and see how it looks like in the code. In this episode, we're going to make a simple task managing console app. It is simple, but you'll be able to see how QObject and core concepts work. By the way, you can find the full code in the GitHub repository, and the link is in the description, of course. As you see, I opened the editor. In the previous episode, I showed you how you can create your project, but now I want to create a separate project for this episode. So let's hit create project the same way as we've done it before, Qt console app. I'll name it the same way, tutorial to video, use default. Here specify CMake, skip, skip, and skip. And you have your project. As we created our project, let's right click on the name of your project and hit add new. Here I want to choose C++ class because I want to add C++ class, of course. And it will make us header and source files. So let's name the first class as task. Here in base class, let's choose QObject, and as you see, include QObject and add QObject macro is also checked as we selected base class. And here let's capitalize header file and source file names. Then hit next and finish. The first thing I should mention is that if you take a look at the cmakelist.txt file, you'll see that names of just added files were added to add executable function. If you, just for the testing purpose, comment those names, files, and you save it, wait a bit, as you see, files won't be added to the final build, and you won't be able to see them in the project structure view in the editor. You see here you have only main CPP. So let's uncomment it, and it should be here. Now let's go to the header file and see what is happening here. The first two lines and the last one have to deal with macro called task_age. If you haven't seen a similar code previously, you're probably confused and don't understand why they added. The thing is that include directives, when you, for example, here write include and task, this line of code, this include, are being replaced with the actual code on the preprocessing step during compilation. So it means that if you write include 2 times, for example here, or in it can be in the another file, and like 2 times in your project, in a complete project, then the code from that class, from the header, will be pasted 2 times, and your executable file will wait more. So using this technique, with defining a macro and checking if it exists or not, we just avoid multiple copies of the header after the preprocessing step of compilation. We also, just interesting stuff, that we also can replace it with the pragma once, and it will work the same way. It makes the same as done it before. But if Qt suggests us to make it in that way, then let's just leave it as it is. Then you see the actual class declaration. It inherits QObject class and has that one QObject macro. That is macro, if you hover your mouse over, which allows you to use all goods of meta object compiler, such as, for example, signals and slots. We can delete it for now. After the macro, you see the constructor with an optional parameter, because you have default value, optional parameter called parent. I previously mentioned that objects organize themselves in object trees, and this is actually it. We have parent, and if you go to the source file, you see it just takes it to the QObject constructor. So okay, let's add a little bit of our code, just so you know what we are writing. We'll have 2 classes, task and task manager. The task will contain a description property, is completed, like boolean, that shows us is it completed or not, a method to complete the task, and a signal that will be emitted when task is completed. And meanwhile, the task manager, that the second class that we will make, will contain list of tasks, like list of those objects, add task method, and complete tasks method that will complete all tasks inside, and a slot to notify when a particular task is completed. So okay, let's start. I will start with the private section. I want to add here first this qstring description. I also have to include qstring. And of course, I forgot, here I also will change the constructor, because we want to receive a description, because it is required. Every task should have description. And here let's also change it in source file, and just description to the description. I'll just assign it. Then you see here prefix m. Why I use it? Because it means that it is member variable. It's the kind of naming convention, you know. And also boolean m completed, that we assign to false as we create our object. Completed to false. Fine. And also let's add the getters for our private properties. So just QString description, I'll copy it just so it quicker, and bool completed. So we can get description in this completed from the task manager. Of course, we have to implement it. I know it's one line, but let's make it correctly. So if you right click and go to refactor, you can add definition to task CPP. Of course, you can do it manually, but I prefer that way. And here we just return description and description. Also the completed and return completed. Before we add methods, I mean method to completed, let's also add, okay, let's leave it in the public section and create one more section for the signals. Here I know if you come from the just pure C++, it's strange for you, but why it works? Because we have QObject macro. That is the reason why we can write it like this. I'll show you more deeply later after we run program first time. And the signal that we create is with task completed, and we pass here string description. Of course, constant, because we don't want to change it in our slot that will be connected. And that's all what you need to do. I know it seems like it's method, but you don't need to implement it. Signals are just signals. You implement slots. And the last step left for us is to add and implement complete method. Refactor and definition. And here, if task is not already completed, just to validate completed, then we assign true to the m completed. After that, let's write message qinfo, as I showed you in the previous episode. It's like the easier way to write something. And of course, we should include qdebug header. Of course, you can use also qdebug or wherever you like, but I prefer here QInfo. And task completed. And let's also output description, so we know what task is just completed. And after that, the interesting part is that we should emit task completed signal. When we emit it, all signals connected to this, all slots connected to that signal will be called with the parameter, with the argument we pass in here. And we pass here description. Okay, fine. Before implementing the task manager class, I want to start with something simple and show you how signals and slots work on the lower level, I mean. So let's jump here in the main CPP file. I'll delete comments. And let's create two task objects. So task1 is equal to task, I don't know, buy groceries. And let's specify as a parent our application. Here we should put a link to it, just to not leak memory. And when we specify it a parent, we don't have to add that one delete statement at the end. We can just skip it, and memory won't be leaked. And second task, let's say fix bug. Then let's just call sorry, complete, and the same with the second task, complete. But now if we run it, nothing interesting going to happen. I mean, you can see I run it, and as you see, just task completed, nothing interesting. Okay, now let's add simple function and make it a slot to the signal inside task, and make it slot for that one signal. As you see, we had that parameters. I mean, we can receive it. So copy that and go here, void on task completed, for example, and put parameters. I mean arguments, sorry. And here, let's also include one more time QDebug to write some message, and QInfo. Let's show that it's our slot. Task completed. Description. Nice. So to connect signal and slot, we have one function, static function in QObject. So we can write QObject and call static function, call it connect. Inside connect, there's 5 overloads, as you see, but the simplest one that we'll use now is just when you pass task 1, so the first object, and I mean pointer to the first object, and link to method, sorry, not method, but signal, and then you just pass name of the slot that is connected. And let's do the same with the second task. And as you see, we can, to one slot we can connect those two signals. And now it's more interesting, because if you run your program, wait a bit, it's building, and you see here, I hope you see it. If no, now you see it. Task completed. It's message from the task class here, and then slot task completed. So our slot was also called when we emitting signal, slot is called. We connected it right here. And as we have some code with the meta object compiler, I can show you what QObject macro is actually for. I mean that one macro right here. If you open your directory where your project is located, for example, here's mine, then you can see your, of course, files and build directory. Let's go to the build, debug, and here your build. Let me make it bigger. Inside you can see underscore autogen folder. Go ahead, click it, and here the most important files are that one, MOX compilation CPP. I'll open it. It opens in the Visual Studio Code, and what it's doing is including that file. So if we go here, we can see the actual file with the mock underscore and then name of our class. So if we open it, you can just take a look for the interest purpose. As you see here, warning, all changes made in this file will be lost, and it is not recommended to make some changes here. It makes no sense, but just to take a look, you see here names of our object, of our signal, of parameter we pass in. It's the structure here. Then you see some metadata, and that's all what is interesting about it. And I will show you later that for every QObject class, a separate file is made. So for the task manager, There's also gonna be separate file with mock underscore something. Now let's implement the task manager class. The same way, create, add new C++ class. Here I'll name it task manager, QObject, and here let's capitalize also. Next, finish. Fine. Like the same way you did it with task. And as you see, we also have it in our CMake list.txt. Okay, let's jump to the header. As you see, structure is the same. And first of all, let's rename to the private and create QList with task pointer to the tasks and name it tasks. Of course, we have to include the QList and include task.h. It's just containing the list of tasks. For now, you can think of QList as of just a list from the standard template library. We'll discuss Qt containers in one of the next episodes, so don't worry about it for now. Now I want to add slot to notify when task is completed. And here I write public slots. In the same way, I mean, you probably didn't saw that keyword before, but QObject macro allows us to do so. And void QString description. Fine. And now we can add the methods to add task. Task and complete all tasks. Now we have to implement it, and of course, as I said before, slots are also have to be implemented, because slots, it's as in this example, it's like function. In our case with task manager, it's gonna be method. Let's refactor. Let's add all definitions, and in the add task, we're gonna just first thing is task set parent to this one. So we want to build that like actual parent children tree. We would build it hierarchy. So not everything is the children of application, but I mean children. But I want to just build it hierarchy, you know. And then connect. And now it's interesting because you see, before we called a static method of QObject, but now because we are inside the QObject, we can call it just as it is. And now it's a bit different, but it will make sense. So first of all, you provide pointer to the object, then link to the signal, task completed, then pointer to the because this is actual pointer to our object that we are in now, and pointer to the slot, and now it's connected. And mtasks append task. Fine. Then in the complete all tasks, let's just make for loop and task and tasks. And here task, let's just call complete method. And if when we call it, then mCompleted is assigned to true, and a message is written, and signal is emitted. And when signal is emitted, then our method, sorry, not method, our slot will work, will make something. We will just write message. And here the same as we done it in main. I'll just copy it and make a small change, just not just slot, but task manager. And that's all I want to change here. So now let's jump to the main CPP. I will comment everything we have written so far because it's another example. And then let's write here. First of all, I want to make task manager object. So task manager equals to new. Oh, sorry, I forgot to include it. Don't forget to include it. And here we provide as a parent A. Of course, to not leak memory. Don't forget to do that. And task, let's just copy and paste. Let's make 3 tasks, just so it have some difference. And name it more simple, just task 1, task 2, and task 3. You see now warnings, but they will go as we finish our code. Fin manager, then we add in it. And oh, sorry, here I copied and specified as a parent application. But now let me show you one interesting thing. Here, as you remember, we set parent, so there is no sense to specify parent here because parent is also set when we add it. Okay, task manager, add task 1, then copy and paste task 2 and task 3. After it, just complete everything with our method. And after we run, let's see what is happening. What going to happen, sorry. Task completed. And where is message from the slot? Oh, sorry. My mistake. I just put the wrong method. I should put here on task completed. Sorry. And now you see everything is fine. So task completed, then task manager, task completed. And as you see, the signals and slots are working fine. And if you open your directory, as I said before, you're gonna have separated files for your QObject classes. So everything is fine, and I think that's it for today. I hope you understood this part because it's really important, and see you in the next episode.